Okay, in this video, what we're going to do is calculate the mass of a hydrate from molecules of hydrate. And so let's see, I'm going to write that goal down. So we're going to calculate the mass of a hydrate. So calculate the mass of a hydrate from molecules of hydrate. All right, now let's just talk for a minute about what a hydrate is. So you can see the model one that we're going to use is up here at the top of the screen. It's called magnesium sulfate hepta hydrate. So magnesium sulfate hepta hydrate. Hepta hydrate. Hepta for 7. So a hydrate is an ionic compound or an ionic formula that is in a complex with a certain number of H2O molecules. We indicate that the compound is in a complex by the use of this dot right here. Now, the dot does not mean multiplication. The dot actually means plus. So if we look at this in a literal sense, what this dot means is that this is MgSO4 and 7 H2O molecules. So we're going to need to calculate the molar mass of the magnesium sulfate heptahydrate compound. So let's go ahead and do that first before we get into anything else. So the magnesium is going to be worth 24.31. That's grams per mole. All right, and I'm showing the relevant information that we need down here on the bottom of the screen. That's going to be added to, we've got 1 atom of sulfur in this, so it'll be 32.07. Plus, there are 4 oxygens. Each is worth 16. And then we need to add to the total here. We need to add 7 water molecules. And each water molecule is worth 18.016. So the grand total for the molar mass of the entire hydrate should be 246, approximately 0.5, and that's grams per mole. The first part of this in here should be equal to 120.38, and this part should be 126.112 grams per mole. So the total molar mass, which we're going to be using above in the calculation, should be 246.5 grams. All right, now let's go ahead and work the problem. Now, what are we going to have for molecules? So what we're going to assume is that we have 1.3 times 10 to the 21 formula units of the hydrate. All right, now a formula unit is the same thing as a molecule. I'm going to use the terms interchangeably in part because I want the viewer to become more comfortable with the idea of a formula unit. It's treated the same way as a molecule. So here I'm going to write the formula down again of the compound that we're dealing with. So it's magnesium sulfate, 7 H2Os, or heptahydrate. In the first step of the calculation, we need to go from formula units to moles. So for this problem, to solve this problem, we're going to need 2 unit multipliers. The first is going to be Avogadro's number, which I'm going to abbreviate as N capital sub A. And the second unit multiplier is going to be molar mass. And Avogadro's number is 6.022 times 10 to the 23rd. And that's, I'm just going to use the term units. It's 6.022 times 10 to the 23rd units, or particles, or apples, or oranges, or atoms. It's just simply a particle. So now when we come back up and we look at what we're trying to calculate, so we're trying to solve for moles here. I'm going to go ahead and write down the unit we're solving for. It's moles. We need the unit, formula units, to cancel out. So we're going to need mole in the numerator, and we're going to need Avogadro's number in the denominator, or the bottom of my fraction. So it's going to be 6.022 times 10 to the 23rd. And to be consistent, we can write formula units. I'm going to abbreviate this, formula period units. And the moles that we're going to get from the calculation will be 0.0022. So we took this number over 1, this number over 1 times 1 mole over 6.022 times 10 to the 23rd formula units. So that's the same thing as saying that we're going to take 1.3 times 10 to the 21 and we're going to divide it by 6.022 times 10 to the 23rd. The formula units cancel out, and we have solved for moles of the MgSO4 dot 7H2O. Now, the goal of this was to calculate mass. So we've completed step 1. Now we need to do step 2. So what I'm going to do is I'm going to pull down my moles of the hydrate for the second step. So we have 0.0022 moles. I write my units and put in my correct label so I know what it is I've got. And now I'm going to multiply by my molar mass. We need G's in the top and we need moles in the bottom. Don't forget that this value here is over 1. So the mole here is going to cancel with the mole here. And my molar mass is 246.5. Write it up here. So the grand total here, when we take the moles and we multiply by the mass, is going to be 0.5323 grams of the hydrate